Hello. Um, yeah, welcome back. Last time we were looking at file IO, and basically being able to write to disk some, um, I guess, data. So there was a few things I had a look at last time. So it's been a little bit of a while, been a bit of a heat wave here. So not really wanted to set and record these videos, but yeah, back now. So let me just quickly go through this function now. Yeah, so the way it works, you create a file handle, check that the file handle is valid. So this is our arena save point again. So this just helps us easily pop off the amount of bytes, and we'd have to think about the alignment. Sorry, it's about reading from disk to, we're reading from disk into our arena. That's what we're doing. Today we're going to be writing to disk. There were a few bugs actually in this one. So we use this quad part of this union struct for our data, and then we push the bytes from our file to the data. So this is actually wrong here. So size of file size is the size of the type size. File size is the size. So this is like a few bytes, when in reality it should be this. So we are actually going to be adding the null byte here to tell it when we've finished. We do have to actually manually add that out down here. So as you see, we've gone through our file bytes array right to the end, and added an extra byte. And that is our read function. So how about now we look to write. Okay, so file data, write file. So I'm gonna need somewhere to write to, some data to write. I guess that would just be a normal char pointer, and we need the size of the data to write. But I think that actually just should be included in our file data. So I think before we did platform, yeah, we have this file data struct which packs our data that we're reading and writing from and the size. So in fact, all we need to do here is pass in our file data pointer. Okay. I always add new lines of them because I'm still learning how to use NeoVim. Okay. So we said same as this one, isn't it? So we try T, yeah, and we name this path, and we have some file data pointer. What is it complaining about? It just doesn't return. Right, that's fine. So I think it's kind of similar, but we kind of need a handle. Just want to create a file handle to the path. So obviously now we're not going to generic read. This is now generic write. File share read. So I think this before was, can other things read from this file handle when we're accessing it? And now I don't want that. Actually, we'll follow the same thing previously. We have no. Oh. So this is kind of the action if it kind of exists. So previously, if we were to, if the file was to exist on disk, we would open the existing, right? But now, probably best to show in here. Okay, so these are the options, right? And we're going to change it to create always. And I think the rest we're going to leave the same. Okay, so that's going to create a file handle for reading, for writing, sorry, to disk. We will then check how we did here. So I'm going to say if file handle is invalid handle, which return 0. I think if it's, I don't know, I was going to return the 1, but not quite yet. Yeah, so we're going to follow a similar thing here. So we're going to have a D word byte is read. So this is just going to count how many bytes we have written, and then we can check how many bytes we've written to disk, and then we can check if we've written enough. So previously we used the function read file, so now no surprise, write file. Yeah. Int file written equals write file file handle. Then we need the points to the buffer, which is going to be our data. Although that is in our file data, right? So file data as a pointer, so dereference it, data, file data, you want the size. We will then write into bytes written. And the LP overlap, I'm not 100% sure what that is. Right, well, that doesn't look like what's needed, so we can know that. Right, very important. We want to then clean up our handle. Oh, we don't actually have to need that. Oh yeah, is that actually called data? No, it's file bytes. And then we're going to do a kind of similar here. So we want to check if let's check that it's written. So return file written, right file written, and that we've written all the bytes. Bytes written is equal to file data size. So let's return 1 if correct and 0 if we've not. So we can then handle that. And I think that's actually all there is to it, to writing. So now let's actually test this read and write capability, right? First we'll test that it compiles. Seems to, that's always a good start. We need to plug it into our API, right? So let's go back to our platform. So then we want int write file const wchar t pointer as the path, and okay, so then game engine dot platform API. And then game engine platform API dot write to file okay, still compiling. Right, so that is let's so I had in the episode 1 where I basically laid out kind of what I wanted to do. I made this goals.txt, right? So let's kind of use that as a test. So let's init our game engine. And we're going to just do it here. We're just going to test it by manipulating kind of manipulating just use it in main just as a test. So what do we need? So first it's our const. I wonder if it is just going to be, if I can prefix like this. Probably not then. path read. And we will actually just rename it just for show. That we can move it around, right? So let's then have a file data called goals, and we'll initialize that to 0. Okay. So let's just kind of bypass the API at the moment, and we'll just call Win32 write file ourselves. As you see, we kind of, we're going to need to pass an arena though. All right. Scrap this just at the moment. We're going to have to do this in Game Engine. I'm going to do it in a Game Engine in it, right? Because we can mess around with some of the arenas that we have in here. Okay, so then we can get platform API dot read file, and we will pass in path read. This returns that, doesn't it? So path read and arena perm, right? Oh yeah, because it is inside the engine. File data pointer, maybe it's not meant to be a pointer. No, because it returns the pointer on the actual arena, so it is meant to be a pointer. Okay, so we've read that to into our arena, red and goals.txt, hopefully, to our arena. Because I'm hoping it's takes it from the root of the thing. So then let's see what happens if we then just call engine platform API dot write file write it here and write that to disk. Okay, it's compiled. Hasn't crashed. And now hopefully we have a goals.txt and a goals.txt. As you see, they're both the same. So you can read successfully from disk and write. That is good. Cool. Let me just remove some of this. Okay, so what would we be using that for? Well, we'll be hopefully having logging set up where we can log to disk some of the stuff that's happening. We also will need it to read and write shaders for the renderer, and we'll probably move on to the renderer next. I know it's quite a short episode, but there's not too much else I kind of want to go through. Maybe I'll have a think quickly. Maybe we can tackle some tech debt. So create window, destroy window, pump messages, init memory, destroy memory, read into file, write file. So let's kind of set up, I guess, what we might need for next time. I will be following kind of very similar to how I did platform, right? So we're going to have a renderer API, I think, maybe the best way of doing it, and being able to attach like a renderer. So for example, like if I want to load OpenGL or load Vulkan, I can have this render API and then have function pointers in here. And when I bootstrap them in main, I'll then do a similar thing where I so this game engine will contain a render API and we'll use it from that. I think that kind of makes the most sense. Also know OpenGL is weird in Windows in the sense that you have to load a 1.1 version of OpenGL and then use that to load in later versions. So there's going to be some funny business that we've got to do. But I think this is how I want to do it. Let's have a renderer and then would have like and then have like OpenGL. That's what I think anyway. Right, we'll have to think about that. I think that's pretty good for a first episode back, only 25 minutes. But we have our reading and writing doing. I think maybe we're going to do the render next, or maybe the logger. Logger's kind of more boring, but would help us debug stuff in the future. So maybe that's a good idea. Cool. Anyway, I think we're making decent progress so far. So thanks very much. See you soon.